Section 3.6 is on combining functions. This consists of two basic parts. The first one, we learn about adding, subtracting, multiplying, and dividing functions. And the second one will do composition of functions, which is has this little circle as a sign, denoting the operation. So first, f plus g is a function constructed from functions f and g by, you have to say what it does to an input. So you add two functions, you define that by saying what it does to an input x. So this is read f plus g of x, and you need the parentheses around the f plus g so you know that that's a single function. F plus g of x equals, now that equals with the colon in front of it means that that's equal by definition. Okay, so equals by definition f of x plus g of x. So you just add the outputs. You use the same input for f and g, but you add the outputs. F minus g is defined by f minus g of x equals, by definition, f of x minus g of x, just as you would expect. So these are not hard to remember. F times g is defined by f times g of x equals, by definition, f of x times g of x. F divided by g is defined by f over g of x equals, by definition, f of x over g of x. So I'm sure you see the pattern there. You just, whatever operation you're doing to f and g, you do that to the output. Of the functions f and g. The domain of each of these is the intersection of the two domains, intersection of the domain of f with domain of g, except for f over g, where in addition to taking the intersection of domain f and domain g, we also have to exclude any values of x for which g of x is 0, because we can't divide by 0. So when we say the domain is the domain of, say, f plus g is the domain of f intersection domain of g, what that says is that your inputs x have to be, the values of x have to be in domain of f and in the domain of g. Otherwise, you can't plug the number into both f and g.